Welcome viewers, in this video we will see the solved problem based on the tuned circuit, problem number 3. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, tuned circuit, problem number 3. We know that tuned circuit means we are making the inductive reactance equal to capacitive reactance so that the circuit behave like a resistance, only the resistance. Single tuned means capacitor is connected in the secondary side in order to bring the resonant condition. Similarly, the capacitor connected in primary as well as secondary means double tuned circuit. Right, now we'll go to the problem. In the single tuned resonant circuit, the applied voltage in a primary coil Eg equal to 20 voltage. Rg is assumed as 0, source resistance. R1 equal to R2 equal to 5 ohm. L1 equal to L2 equal to 32 microhenry. Mutual inductance is 20 microhenry. The capacitance in the secondary side 0.5 microfarad. So the source voltage given, source resistance 0, R1, R2, L1, L2 values are available, mutual inductance available, the capacitor at the secondary also available. Determine the resonant frequency and the output voltage at this frequency. We need to find the two parameter, resonant frequency omega r and output voltage at this frequency E naught. Right. First we will find the resonant frequency. From the given data, we will find the resonant frequency. Omega r equal to 1 divided by square root of L2 into C. So these both the values are available. L2 is 32 microhenry, that is 32 into 10 to the power minus 6. C value is 0.5 microfarad, so 0.5 into 10 to the power minus 6. So by simplifying we got 0.25 into 10 to the power 6 radian per second. So the resonant frequency is calculated. So at this resonant frequency we will find the output voltage. At omega r the output voltage. The formula is E naught equal to Eg into M divided by C of R2 plus Rg plus R2 plus Rg into R2 plus omega r square into M. All these values are available. Eg is 20 voltage, mutual inductance 20 microhenry, so 20 into 10 to the power minus 6. Capacitance is 0.5 microfarad, so 0.5 into 10 to the power minus 6. Rg value is 0, R2 is 5 plus omega r square, just now we calculated 0.25 into 10 to the power minus 6 square into M. 20, M is 20 microhenry, so 20 into 10 to the power minus 6. So by simplifying this, what we got, 0.64 into 10 to the power minus 3 voltage. The output voltage is 0.64 into 10 to the power minus 3 voltage. So in this problem, from the given data, we calculated the resonant frequency and output voltage at the resonant frequency, two parameters. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.